Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give 3 examples related to finding the basis. So we're going to find the basis for the span of the given vectors. When you have this type of, for example, different vectors to be considered, what you can do is we can consider the same process which I have explained in the previous video. So you're going to combine all the vectors given into a matrix. So you will create a matrix, and based on this matrix you can apply again the ERO, elementary row operations, so that the matrix here will be reduced to RREF. Okay, now from this reduced matrix, you should be able to identify the column that has leading 1. So this is the same column that you should go back to the original matrix and consider particularly the same column, yeah. So you will consider the same column in this original matrix A, and that will give you the result of basis for the span of the given vectors. So this is what we're looking for, and again the process is similar to what you have seen in the previous video. So without further ado, let's jump in straight into this particular example here. So we have a span of these 3 vectors here, which you can combine all of them together into matrix A. So this is how the matrix looks like: 1, -6, 7, 2, -8, 6, 3, -7, 11. So the first step is to change this to 0. Here we will transform the second row plus 6, the first row, and the result that we have is 1, 2, 3. Here's -6 plus 6, 0. -8 plus 12 is 4. -7 plus 18, so that will be equals to 11. Also, this part has to be turned to 0 as well. So we will consider changing the third row with this operation. Okay. So 7 minus 7, 0. 6 minus 14, it will be -8, yeah. 6 minus 14, -8, that's right. So 11 minus 21, so 11 minus 21 is negative. So here we have 11 minus 21. Sorry, this is not 11, this is -1. So how did I get into a different value? Well, I'm not sure. Okay, let me just erase this. So here is actually, oops, sorry. So here is actually -1. Have I got all the numbers correct? 1, -6, 7, 2, -8, 6, 3, -7, -1. Okay. So well, based on that, -1 minus -21 is -22. Okay. Right. Next is well, I can just perhaps consider dividing this part with 2. Okay, so that we can see this row here is just 2 multiplied with the second row. So what I'm going to do is I'm just going to divide that with negative 2. So the third row will be divided with negative 2. And here we will have 1, 2, 3, 0, 4, 11. Here I will have 0, negative 4 times negative 1 over 2 is 4. Negative 22 with negative 2 is 11. Okay. Then what I can do is I can consider getting rid of everything here to become 0. So that can be achieved if I consider the third row plus negative 1 of the second row, and I will have this result 0, 4, 11. So 0 minus 0 is 0, 4 minus 4 is 0, 11 minus 11 is 0. Next, I'm going to change this to be equal to 1. So 1 over 4 multiplied with the second row. And the result that I'll get is 1, 2, 3, 0, 1, 11 over 4, 0, 0, 0. And in order to be RREF, this part here has to be 0. Okay, so I'm going to transform the first row and using this operation. And the result that I get is, well, 1 minus 0 is 1, 2 minus 2 is 0, 3 minus 22 over 4. So 3 minus 22 over 4 is, well, negative 5 over 2. And then we have 0, 1, 11 over 4, 0, 0, 0. So this is RREF, okay? Based on this RREF, I can identify the column that has leading 1. So here is the column that has leading 1. This is also the column that has leading 1. Therefore, we are just going to consider the original matrix with these two columns. So the original matrix is up right there. Okay, so this is the original matrix. Therefore, we are going to consider this column and this column, and these two columns here becomes the basis for the span of the given vectors. Okay, well, let me just erase this part so I can write the conclusion properly. Okay, so based on the results that we got, we can say that therefore the basis for the span of the given vectors is equal to 1, negative 6, 7 and 2, negative 8, 6. So this is the answer. Okay, right, let's move on to the next example. Here we have got massive vectors that we need to consider, and we are going to follow the same process that I have already shown you just now, and we're going to start combining all the vectors here into a matrix. Okay, so the matrix is going to look like this. 1, negative 1, 0, 2, 1, 2, 1, negative 2, 0 and 0, 0, negative 3, 2, 4 and 2, 3, 3, negative 4, negative 2, negative 1, well, 2, 4, 1, 0, 1, 5, 7, negative 3, negative 2, and 0. Wow, so we have 5 by 6 matrix. Okay, now I'm going to turn this into 0. So I have to consider the process here, R2 plus 1 R1, and the result is 1 2 0 3 2 5. And for the second row, it will be negative 1 plus 1 is 0. 1 plus 2 is 3. Negative 3 plus 0 is negative 3. 3 plus 3 is 6. 4 plus 2 is 6. 7 plus 5 is 12. So that is the result for the second row. And this is okay, this is already 0. So next is turning this into 0 as well. So that is the fourth row plus negative 2 first row. Okay, so here I'm just going to write down the third row as it is, negative 2, 2, negative 4, 1, negative 3. So for this one is 2 minus 2, 0, 0 minus 4, negative 4, 4 minus 0 is 4, negative 2, negative 6, so negative 8, 0, negative 4, negative 2, negative 10, negative 12. Okay, so that's the result here. And of course, for the last row here, this also should be turned into 0, and therefore I need to consider the fifth row plus negative 1 of the first row. So 1 minus 1, 0. 0 minus 2, negative 2. 2 minus 0 is 2. Negative 1, negative 3, negative 4. 1 minus 2, negative 1. 0 minus 5. So this is negative 5. Whew. Okay. Right. Next, what I can do is I can turn this into the value of 1. So I will consider 1 over 3 multiplied with the second row. And the result here is going to look like this. Okay, so what we have is, well, 1 2 0 3 2 5. Yep, that's the first row, and everything here will be divided with 3, so we will have 0 1 negative 1. So here we will have, oh sorry, hang on, so here I will have 0 1 negative 1. So 0 1 negative 1, 2 2 and 4. Okay, 2 2 and 4, and the rest will be just the same numbers given here. So that would be 0 negative 2, 2 negative 4, 1 negative 3, negative 2, 2 negative 4, 1 negative 0 negative 4, 4. So here we will have 0 negative 4, 4 negative 8, negative 4, negative 12. 4 4 8 4 12. 4 4 8 12. Things negative. Okay, and finally we will have 2 2 different 5. Okay, so here we will have 0, -2, 2, -4, -1, -5. Okay. Now what I can consider next is I will turn this to be 0. So here I will have R3 plus 2R2. Here we will have 1, 2, 0, 3, 2, 5. Here we will have 0, 1, -1, 2, 2, 4. And for this one, 0 plus 0, 0, -2 plus 2, 0, 2, -2, 0, -4, 4, 0, 1 plus 4, 5, -3 plus 8 is also 5. Okay, and I also need to consider turning this into 0, so that is the fourth row plus 4 times with the second row. So 0 plus 0, 0, -4 plus 4, 0, 4 minus 4, 0, -8 plus 8, 0, -4, -4 plus 8 is 4, -12 plus 16 is also 4. Wow, okay, next. Turn this into 0 as well. So that would be the fifth row plus 2 of the second row. So 0 plus 0 is 0, -2, -2 plus 2, 0, 2 minus 2, 0, -4 plus 4, 0, -1 plus 4, 3, -5 plus 8 is also 3. Okay. Now, the next step that I can do is, of course, to consider changing this to be equal to 1. So here I shall have 1 over 5 times with the third row. And the result here is, well, 1, 2, 0, 3, 2, 5. 0, 1, -1, 2, 2, 4, 0, 0, 0, 0, 1, and 1. So the third row now is changed. This one is 0, 0, 0, 4, and 4, 0, 0, 0, 0, 3, and 3. Well, clearly what we can do next is we can change this to be 0. So here you can consider the operation of changing the fourth row plus -4 of the third row. So the result that we will have is 1, 2, 0, 3, 2, 5, 0, 1, -1, 2, 2, 4, 0, 0, 0, 0, 1, and 1. So here it will be 0 plus 0, 0, 0, 0, 0. So 4 minus 4 is 0. 4 minus 4 is also 0. And in the similar manner, we can change this to be 0 as well. So we can consider R5 plus -3 R3. And when you do that, you will also get everything here will be equal to 0. Right, well, here is the position of this is leading 1, this is also leading 1, this is also leading 1, but we need to turn all the values on this part here to be 0. So we have to continue the process. So turn this to 0, so I have to consider, well, R1 plus -2 R2, and the result here is going to be, well, 1 plus 0 is 1, 2 minus 2 is 0, 0 plus 2 is 2, 3 minus 2, so here is, sorry, 3 minus 4 is -1, 2 minus 4 is -2, 5 minus 8 is -3. Okay, and here we have 0, 1, -1, 2, 2, 4, 0, 0, 0, 0, 1, and 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, so next is so here you can see this is the first column, looking all right. This is the second column, and this is the leading one here. Therefore this part has to be changed to be equal to 0. So, well, what we have is, now we can consider R1 plus 2R3. Okay, so it will be, well, 1, 0, so it is 1, 0, 0 is 0, 2, 0 is 2, -1, 0 is still -1, -2 plus 2 is 0, -3 plus 2 is -1. So that's the first rule. Of course, we also need to turn this to be 0. Therefore, R2 plus -2 R3 is the operation that you need to consider. Well, 0 and 0 is 0, 1, 0 is 1, -1 with a 0 is going to be -1, 2 and 0 is 2, 2 minus 2 is 0, 4 minus 2 is 2, and here is the results, the remaining values, which are all 0. Okay, all right, and I hope you can see clearly that this is the column of leading 1, this is also the column of leading 1, and this is the column of leading 1. Okay, therefore we need to go back to the original matrix, and we're just going to consider, well, the first column, second column, third, fourth, fifth column as the basis for the given vectors. Okay, wow, this is such a long process. Okay, so these are the columns that we have to consider, and if we go back to the original matrix, well, let me just erase the whole thing here. Yeah, therefore the columns that we need to consider again is the first column, the second column, and the fifth column, and based on that we can say basis for the span of the given vectors is 1, -1, 0, 2, 1, and then 2, 1, -2, 0, 0, and finally 2, 4, 1, 0, 1. That's the answer that we're looking for. Okay, right, let's move on to the last example. So consider all the given vectors here. Do they form a basis for this vector space? And we can start with thinking of combining them all in one matrix. So here we have this matrix 1, 1, 3, 3, 0, 4, 1, 4, 1. So what I'm going to do is I'm going to apply the usual elementary row operations to reduce it to RRAF. So for this one here, R2 plus -1 R1. So here I have 1, 3, 1. 1 minus 1 is 0. 0 minus 3, -3. 4 minus 1 is 3. Also, this part should be reduced to 0 as well. So R3 plus -3 R1. So 3 minus 3, 0. 4 minus 9 is -5. 1 minus 3 is -2. Okay. Next is to turn this to be 1. So therefore, -1/3 times with the second row, and the result that we will get is as such 0, 1, -1. Here is 0, -5, -2. Next, what we can do is we can change this to be 0. So the process that we will consider is R3 plus 5 R2. And therefore, we will get this result 1, 3, 1, 0, 1, -1, 0, 0, -5, 5, 0, -2, -5, -7. Okay, next what we can do is we can change this value to be equal to 1. Therefore, we are going to multiply that with -1/7, and the result is 1, 3, 1, 0, 1, -1, 0, 0, 1. This is not RREF yet. So what we can do is, well, we can perhaps focus on this part and turning it into 0. So there will be a change in the first row. So first row plus -3 of the second row times with the second row. So 1 and 0 is 1. 3 minus 3 is 0. 1 plus 4 is 5. Yep. Sorry, 1 plus 3. Sorry. So here is 1 plus 3 is 4. Okay. And here is 0, 1, -1, 0, 0, 1. Okay, next is we shall consider turning this to 0. So the process that we have to do for that one is R1 plus this will be -4 R3. Okay, -4 R3. So here I will have 1, 0, 0. Okay, so you can see 1 and 0 is 1, 0 and 0 is 0, 4, negative 4 is 0. So the first line here will be 1, 0, and 0. Also, this part has to be 0 as well, so you can consider the process of R2 plus 1 R3. And because of that, 0 and 0 is 0, 1 and 0 is 1, negative 1 and 1 will be 0. So the result here will be 0, 1, 0, and at the bottom is 0, 0, 1. So this is RREF. And you can see that the column with leading 1 is the first column, the second column, and the third column. So therefore, if we go back to the original matrix, so we will be considering first column, second column, and third column, which then translates that all the vectors given here form a basis for this vector space. Okay, so we can write down the conclusion as such. Therefore, based on the result, the columns that we should be considering is column 1, 2, and 3 of the original matrix. Therefore, we can conclude that vector 1, vector 2, and vector 3 given is the basis for this vector space here. Okay, so that's the answer to this question. Okay, I think that's all for now. Thank you very much for watching, and I'll see you in the next video.